Hi, good morning. So welcome to Techceleration's 18th edition of Meetup. So it's very nice to see, on a Saturday morning, all coming in for a meetup. It means a lot to us. So this is even more special because this is our first time we're doing an event in the Bangalore office, and also the first time collaborating with the MongoDB team. Thanks to the Mug team and the Darshan and his entire team. And I would also like to kind of, say that, like, we're going to begin now with Vivek. He's going to talk about the data modeling in MongoDB, and then followed by Ayushi. She's going to be talking about the transitioning in the replica sets, and then moving on to to Deepak, who's going to be talking about the search use cases. And we're going to have a trivia in between where Darshan is going to run the trivia. And post that, we'll have networking lunch, and there is also cool swags for all of you. Yeah. So enjoy the event, have fun, and please do share your feedback in the page and also in the Mongo site. Yeah, I'm just going to invite Narsiman to say a few words. He's one of the tribe leads from Toyota Connected.
Closer. Okay. Good morning. No energy. Okay. Good morning. Yeah. So welcome to the 18th edition of Tech Acceleration. I mean, um, it's 18 is kind of a special number. So first time in Bangalore, like I mentioned, and it's a great platform for all of us to kind of collaborate, learn from each other, and like all of you know, technology keeps changing every 6 months, so it's very critical that we're all up to date with technology. And it's a great platform, and I believe we have like more than 1,000 odd participants last 17 sessions. Um, and about the speakers, Vivek from TCA, and I have closely worked with Vivek. He's going to share a lot of insights this. And of course, I'm very happy that first time in Bangalore. Um, so welcome you all, and happy learning. Thank you.
Thank you, Narasimhan, for giving a welcome talk. So let's just begin with a first talk. So our first speaker will be the Vivekanandan. Vivekanandan is currently working as a lead software developer in the TCIN, and along with the software development, he also work with databases, especially the MongoDB, Postgres, and whatnot. Also, he have a certification in MongoDB developer and AWS cloud practitioner as well as the associate solutions architect. So I guess like we'll be learning a lot from Vivekanandan. So today he will be talking about the data modeling. So data modeling plays a crucial role in any database, you name it, right? So the modeling, how and why it impact your performance overall. So he will be covering today. Stage is all yours, Vivekanandan.
Have to use the mic. Hope I resemble close enough to my infographics today. And I think there's need for any slide anymore. I think Darshan gave me enough introduction for myself. And then in Toyota Connected, we build products that improve customer experience and also products that goes into anywhere of our life cycle. So these are the numbers that we did last year. So we operate around 842K users, and we process 4K transaction per second of vehicle probe data. And it's we also allow the customers to execute remote commands. That's more like every vehicle executing a remote command every minute. And we also have around 20 to 25K active users. I was lazy to pull the exact numbers from Firebase. So, and we manage around 2.3 millions of vehicles in India. And getting into the topic, so these are the two papers that change the way how database landscape works. One by EF Cod on relational model in 1970, and another by engineers at Amazon on a highly available key-value data store. EF Cod theorized relational model. He talked about Cartesian products, primary key, active domain, and referential integrity and whatnot, which laid groundwork for building modern relational database engines. And then this people believe that relational model is the definitive way to store and manage the data. They wanted to enforce constraints on data for its data integrity so that they can avoid data anomalies. For the next 30 years, relational model was the only choice for enterprises for their OLAP and OLTP workloads. Oh, sorry. For the OLTP and OLTP workloads. So relational market grew to be a value of over $15 billion in the year 2007. It was the same time Amazon e-commerce website suffered scalability issues. So they had to denormalize all the tables that they had and vertically scale up the engines to increase their throughput. So that's when they figured out that the only way to solve the problem was not to scale up, but to scale out as well and to distribute the load. That's when they built Dynamo and also made it publicly available. So Dynamo is capable of scaling out and also storing redundant copies of data to provide high availability and to tolerate network partition. This paved the road for building non-traditional way of building databases. So when all of a sudden NoSQL databases became rampant, people started adopting it. Oops. People started adopting it. When this disruption happened, there was a shift in responsibility. Since there are no tables, no referential integrity, it's no longer the responsibility of the database to enforce constraints during the write. Now it's the responsibility of the application to manage the life cycle of a growing schema. So that brings us to the objective of this talk. So during this talk, we'll see how to approach data modeling in MongoDB, how to deal with the relationship, and how to enforce constraints during the write. And also we'll look at some of the design patterns that can help us to improve the query performance. So if you are from a relational world, migrate your tables directly into collection. And if you are using MongoDB with normalized data, then that's going to affect your query performance as the data grows. So in relational model, it's all about removing the redundancy and normalizing your entities. In MongoDB, it's not about removing the redundancy. It's about finding that perfect balance between your normalization and application needs. So let's take a quick look at schema modeling in relational database. So in relational model, we'll start with defining our entities. We'll list out each and every attribute of our entity, and then pick one of primary key as one of the active domain. And then we'll figure out how these entities are related together and find the cardinality of this relationship. And finally, with the help of primary key and the cardinality of the relationship, we'll start formalizing the data. So we start formalizing the data so that we can remove the redundancy. And finally, we identify the workload and plan our queries. So the problem with the relational model is that the data dictates. The data that you have initially defines the number and shape of your tables in your application. And anywhere in the process, relational model does not consider the data access pattern or nature of the workload, whether my app is read heavy or is write heavy. But in MongoDB, we do the other way around. We start with analyzing our workload and see if whether my workload is read heavy or write heavy. Does my schema model should favor one of these operations. And then we'll move on to identifying this relationship between the entities that we have and see whether to embed or reference to improve our query performance. And also, we applied some of the design patterns in MongoDB to improve our query performance. It's about denormalizing your data so that it can retrieve the data in a single query. For this presentation, I've taken a TPC workload. TPC is a decision support benchmark for OLTP workload that tries to measure the number of transactions you can create using any database management system. So TPC is a quite old benchmark. The last version came around like 2010, and it's it's fully based on a relational databases, but I've seen a lot of NoSQL database supporting enterprises adopting these benchmarks. So this benchmarks has read and update intensive queries. This benchmark, this workload tries to measure number of transactions you can create MongoDB as well. So I think one of a person from MongoDB has created this benchmark, and you can find it online. The workload describes about a company where the company has n number of warehouses, and each warehouse, the company can stock up to 100,000 items, and the warehouse can support up to 10 districts. And each district, the company has maximum of 3K users. So this platform allows the customer to review and rate their product as well. But reviewing the product is not part of the TPC benchmark I've included for this talk. So the first step in our schema modeling data process is that we have to identify our workloads. So identifying the workloads is that we have to identify the query and data access pattern. So with the help of our functional, so these are the functional requirements of our application. The platform should allow the user to create order, update the payment for the order they have placed, and also the user can come back and check status of the order. And once the payment is processed, we also dispatch the order for delivery. And also we have some back office people where they can examine the stock level. So with the help of the functional requirements, we'll see what data is accessed together, and what is the frequency at which this data is accessed, and what is the common queries that used by this operation. So first, we'll identify the list of entities in our application. So to begin with, the company has n number of warehouses. The company has n number of warehouses. So we'll also the company plans to operate across. If the company plans to operate across India, that would be like we have 777 districts in India. So that would be of around 77 warehouses to support those districts. So the company initially starts with 10 warehouses and have plans to scale across all the districts. So we have 2 entities now, and also we also have stocks in our warehouses, which is sort of item. So we have next 2 entities, which is item and stock. And the company initially stocks up to 100,000 different products, which is of stock 100, which is so 10,000 items, which is of 100,000 stocks. And the company operates in 10 districts, and the company has maximum of 3K users in each district. So that sums up to 300,000. And the company has initially dispatched around 150K orders, and they also have, if they scale to 77 warehouses and serving up to 778 districts, that would be around 1 million. And so and on average, the customer orders 10 items per order. So that would be around, if there are 150K orders, that would be around 1 million. And we also allow the customers to review the orders or items they have purchased. So they already have 40,000 reviews, and we would be expecting 5,000 reviews every month. So the next step in our workload identification is to list the operations that are performed by our application. So in our platform, we allow the customers to search for a product they are interested in. And we also have to flag any product that is out of stock or not available in the warehouse that's responsible for dispatching it to the customer. So we'll define the operation as search, and the nature of operation is read. The entities involved here are item, district, warehouse, and stock, because we have to flag any item that is out of stock or not in the warehouse. So next, the customer can narrow down the search and land on a product page where we have to showcase product details along with the average rating and number of ratings and most recent and most useful reviews by the customer. So the nature of operation is read, and the entities involved here are item that the customer is interested in, and the reviews for the product, and districts in which district and warehouse in which the customer is mapped to, and the stock information. And a customer can add that product and place an order. So the operation would be like new order. The natural operation is write. So the entities involved here are customer who is placing the order, an item, the district and warehouse where he is mapped to. Once the order is placed, the customer can do a payment using his credit or debit card. So this payment has to be reflected against the order as well as warehouse and district statistics. So the nature of operation is right, and the entities involved here, customer who is paying for the order, district and warehouse. Once the payment is processed, the item will be dispatched for delivery by back office people. So we have to update the status of the order against it. So we have nature of operation as right, and the entities involved here are customer, order, and line items. There could be a scenario where line items are dispatched for delivery, but not the entire order itself. And the customer can come back and check status of order anytime in our platform. So the nature of operation is read, and the entities involved here are customer, order, and list of line items. So we have a feature in on a platform where it sends notification if an item goes out of stock or goes beyond a threshold. So here the entities involved is only the stock information of an item. So I missed item here. So stock, and the type is read. And we also in our platform, we also allow the customers to rate and review the product. So the operation is review product, type is write, the entities involved here are customer and the item. So once we have defined our operations, the next step would be identifying the frequency at which this operation will happen. So if you have to piggyback to the table that we have defined in the first slide, where we had initially started with 150K users, and the company has planned to scale up to 300K users. Even if 2 or 3% of the people are online, and that would be like comes around 150, 1500 reads per second, and same as for narrowing down to the product page, and we expect minimum of 500 orders per minute. And update payment, we expect all the customers to pay for the order they have placed, and I will be dispatching 50 orders per every hour. And the customer can, since we allow the customer to check the status, that would be around 500 reads per second. And stock level, whenever order is dispatched, our cron will check for the stock level of the items and I'll update it. If it goes beyond a certain level, we'll send the notification. So that would be so every time we dispatch order, the cron will check for the stock level and send notification if that goes beyond the threshold. And also we expect at least 100 reviews per minute. Now that we have defined the frequency of orders, we'll take a look at it. So we have the most frequent operation as the search for a product and drilling down to the product page. So that's the most frequent read operation and the most frequent overall operations as well. So it means that our nature of our workload is read heavy. And the next to read operation, we have the most frequent operation as write. So we have to, which means that we have to optimize our schema in favor to read operation, which is searching for a product and viewing down the product page. So with the help of this frequency information, and this is the rate at which the operation is going to happen. With the help of this information, we'll see how these entities are related to each other and see whether to embed or reference them based on the cardinality. Two applications having the same entities can have different schemas in MongoDB. So one application can refer and embed the address in a customer document in another entity where it can reference it. Whether to embed or reference depends on the data access pattern and nature of the workload. So if it's a one-to-one relationship, you can directly embed them. This is a type typically a has-to relationship where a customer has an address. So an example from the previous slide where we have embedded customer in the user document. So if you have a scenario where the child can exist without a parent, you can create a new collection and denormalize the data as per your application needs. So we'll take an example of this in the next slides. So this is a one-to-one relationship where a customer is always mapped to a district and a warehouse in our application. So we have to denormalize So we don't, if we are using a relational database, we will be doing joins to pull out which district this customer is belong to or which warehouse he is mapped to. We'll be joining the customer collection, customer table, along with the warehouse, along with district in relational database. But in MongoDB, we can denormalize that. So it's unlikely that the address, the customer will be changing the address very often. So we'll embed district and warehouse information in customer itself so that we don't have to do a join or lookup whenever he searches for a product or searches for a stock information. So whenever, so this is snippet, but it's not like a compiled code. So here, whenever we create a customer, we find where is he mapped to with the help of a pin code. We'll find warehouse and district details. When we create an order, so when we search for items, we can easily map whether the stock information is available or not. And the next type of relationship where we can embed is one to few. So this type of entity where one record on the parent side is linked to very few records on the other side of the relationship. Here, this type of relationship exists between order and order line. So order line cannot exist without an order. An order line is always within 15 limits. So even in RGO app where you cannot add more than 15 items to the cart, the maximum item that you can have cart is 15. So in this relationship, so whenever you create an order, we embed all the line items in order collection itself. So and also we have denormalized the collection, the document in such a way that we have embedded both customer and warehouse information. So the order is always mapped to one customer and it's always belong to one warehouse, which is responsible for dispatching it. So we denormalized data in such a way that most of the operation are satisfied in a single query. If we have to piggyback to the table where we have defined frequency, we have to update status of the order, and as well as when we dispatch, we have dispatched it to the customer. We need customer address. So if we denormalize, we don't have to join or do a lookup to the customer collection to pull the address out. So this is an example from our production system where a user is linked to very few vehicles. So in our application, we allow customer to associate one or more vehicles. So here we don't want to do a join or a lookup to retrieve the vehicles associated to a particular customer to pull the vehicle information. Here we have created a denormalized collection. We also have a user collection. We also have a vehicle collection. Instead of doing a join, we have denormalized in a separate collection where we have necessary user and as well as vehicle information. So we can, if you want to retrieve the number of vehicles or associated vehicle information, we can pull that here from this collection in a single query. So other than one-to-one, one-to-few relationship, we have to reference on all other kind of relationship. So this is typically one or more records linked to unbounded or many records on other side of the relationship. So in our application, we have warehouse and stock information, two entities where warehouse can stock up to hundreds and thousands of orders. So, and also we have another type of relationship is one-to-many, where an item can have many number of reviews. If we start embedding reviews into item collection, it's most likely that the maximum size of the document can exceed. So the maximum size of the document is 16 MB in MongoDB. If we start embedding all the reviews in a document, then that would definitely exceed the maximum size of the document. So this is an example of one-way referencing. So for item to reviews relationship, we have referenced item ID in our reviews collection. This is called parent referencing, where in our child document we reference the parent, but in item we don't reference reviews at all. So whenever we create a review, we reference item ID in our reviews. We also denormalized this review document to an extent that we have username, user ID, and as well as user image URL, so that we don't have to do a join or lookup to list the reviews by the customer when we land on the product page. Two-way referencing. Two-way referencing exists between two relationships where many records on the one side is linked to many other records on the other side. A typical example would be like to-do list, where one task is mapped to many users and one task is assigned to many users as well. So here we have referenced owners in task and as well as the number of tasks in users list as well. So next thing is to design patterns. So we will apply some of the design patterns to improve the query performance. So design patterns you might be seen in your application code where we have to improve your code quality, or you might want to improve your. So in our application we have a use case where we have to pull the item information along with the reviews and ratings of our customer. So in our product page, we have to showcase our product information along with average and most recent and most popular reviews. So using computed pattern, we can pre-compute these values. In typical relational database, we do joins whenever we have to pull this information. Whenever we have to list number of items for a review, we join item with the reviews and do a group by and sum. So in MongoDB, we can apply a computing pattern. We can calculate this information during the write of every review. So whenever a review is added, we can do a find and modify. So whenever review is added, we calculate total number of reviews and average rating and store that in product itself. So whenever we want to pull item information, we will have total reviews and average rating as well in a single collection. So another use case is that whenever we view an item, we want to pull out most recent reviews and most popular reviews. So we can apply subset pattern here and denormalize the data. So this is an example of subset pattern where we have embedded most recent reviews and most popular reviews as well. So we don't want to join the other collection to pull out most recent and most popular, where we embed this information during every write of review. So you can see the snippet here where whenever we add a review, we update this document with most recent review, and we can also in the similar way we can update most popular document. So MongoDB is known for its polymorphism, where you can group all the documents having different shapes in a single collection. But polymorphic pattern is more powerful when you have a behavior with your application code. This is an example from our production system where we have behavior associated to each and every remote command, and this behavior for each and every remote command is different. So whenever we pull a document from a collection, the JPA will take care of deserializing the document and converting that into object. When we have an object, we can exhibit a behavior. So we just have to retrieve the document and execute the function so that we can have a different behavior during every retrieval. This is like a must-have patterns for MongoDB in production. So we start with schema pattern, but eventually we will move to a place where we have to break our schema model. So when we have to change our schema model, we need to have some downtime, and we also expect to have some downtime. So if we apply schema versioning pattern in the first place, we can do that without having a downtime itself. So all we have to do is to have an attribute that mentions the schema version. So here we have a schema version as 1. So in our application code, either I can have a query something like which queries schema version 1. And if you don't have a schema version today in production, we can change your query to something like this. So even if you have to change your schema, that break your application code, where if you have this query in your application, you can migrate a schema without having downtime. You can, let's say you have a document that has address as an object, but you want to allow the application users to have more address, so that you have to change your attribute from a type of object to an array, so which breaks your application code. If you have a schema version which queries schema version 1, you might be retrieving only the address which has an object type, and you can migrate that to array type meanwhile, which would not break your production application. So another pattern is like document versioning pattern. You might be face a scenario where you have to maintain a version of each and every document. So this, you might be in a situation where you have to store this because of GDPR regulations. So document versioning pattern is that, so we have a scenario where a document is updated from by different personas from different systems. During the situation, we have to maintain a list of audit for a document. In our relational databases, we have triggers, so which can populate for us, but in MongoDB we don't have triggers. We have triggers, but in Atlas we can execute Lambda or something. But if you want to maintain what are the updates that a document has went through, we can have two collections. One is a primary collection where your application would query from, and you can have another collection where it has an audit documents. All you have to do is a double rates. Whenever your application queries information, you can focus it on the primary collection. That is more of an audit, which help you in future. And also this audit information we have used for GDPR regulations as well. And the extension of document versioning pattern is that field versioning pattern. In your document, your document has a very limited life cycle. Let's say payment is one of a very short span of life cycle, where payment starts from creating an order to fulfillment of the order. So here, what we would do is like we maintain a history for the status only. We don't do version the entire document, but only the specific attribute alone. Here, we would simply create an array where it would have status of the each status of the order upon its life cycle. So I think that's pretty much it. So in MongoDB, if you have to optimize for production, then store everything in one single document. So most of the operations in your application should be satisfied in a single query. And how you model your schema is entirely depends on your application and use case. You don't have to normalize the data, or you don't have to denormalize it too much. Find a balance between your normalization and your application needs. Embed only for one-to-one and one-to-few, and you can also embed for one-to-many use case, but you have to think before you embed it, because if your array grows beyond a bound, that might affect maximum size of your document. And reference for other than one-to-one or one-to-few, and denormalize the data to an extent which can satisfy most of the queries in operation. In our example, we have denormalized order collection, where we had customer information, customer address, warehouse information, and also the order line items, which can be returned in a single query and updated in a single update document. I think that's it for today.
So if you have any questions, you can ask Vivek.
Now we are migrating to NoSQL. How are you handling constraints? Assume that you'll be having uniqueness constraints, constraints on a column length, etc. So this logic now, where it will land? Will it land in the application code, or will you put it into the MongoDB itself somewhere?
Have this layer itself. You don't have to data layer. You can save some CPU cycles before it gets there.
Have you come across any scenario where you need to correct some of your data?
Yes. Day we wait for production, after a week, then all it goes for. So we have to look back and correct the data. That's why I created that audit collection. I was going through AWS CloudWatch to pull all the logs corrected. So if we have that in the first place from day zero, you have to search through your logs and the log information to correct it. You can just look back into this collection, chronologically update the document.
Do you use any APIs to write to that logs? Means libraries to write to that logs, or you explicitly double write?
Have an entity like a customer, you can have an entity customer extends customer audit, and you have to have a DAO have to customer.save customer audit.
For analytical requirements, use same MongoDB, or do you do CDC from this Mongo to analytical stores?
So when you do one-to-one mapping, and if I'm fetching a document, do I fetch the document with reference or do I fetch the document with the other document embedded into this? So let's say if it's one to many also, right? In that case also, what will it, how will the fetch look like in that case? So there is one entity and it is referring to, let's say, 50 other entities. Now the question is that if I'm fetching, do I fetch this document with references or do I fetch this document with those documents which is referring to as embedded into one? So it basically sort my fetching part.
First, you can embed it. You can embed it in a single document. You can retrieve it. That solves all your problems. The two entities can exist independent of each other. In our use case, we have users entity of the vehicles. So we have to, these entities can exist independent of each other.
I have to fetch them separately.
You can denormalize into a new collection. In your relation database, you might have an intermediate table where you have customer ID along with the vehicle IDs. So instead of that, you can have a denormalized data where you don't have to join or look up. You can denormalize in a single collection. Whatever the information needed with the application, you can have it in the new collection.
Can yeah.
My question is also includes a part of AWS since you are familiar with that as well. So say you have a one-to-many, kind of relation, but it's the entries might be too big for the MongoDB 16 DB size. So you are storing it, as an individual entity, but you have too many records. Say it's a SaaS application, so you have too many records coming in. So you're querying a table of, where 10,000 entries are created every day. I mean, a collection. So I'm thinking from, from an archiving perspective, do you guys do that archiving it to a separate collection? Or like say, just for an example, wanted to get your opinion. Say, since we are storing it as we are consuming it, would you prefer archiving it to a separate collection every 24 hours in a cron job, or say archiving the whole JSON, put it in a cold storage somewhere in S3 or somewhere, and then take it only when needed, only store the last 24 hours data? I'm talking about like, thousands of data getting inserted in the same collection every day, where storing it together is also not possible. So you have to reference it as well. No, it needs to store data beyond that, but most frequently queried is the last 24 hours. The other ones are not so frequently queried. So either I'm asking whether it's, good to have an archived collection or keep it in a cold storage somewhere as a plain JSON itself. No, it'll be used, but not very frequently. And then how do you remove it from the daily collection? You replace it or you just delete from the last one? Thank you.
You told you will be writing to multiple tables in one transaction, right? I'm not sure whether the latest version of MongoDB supports transaction. Do you use any transaction outbox pattern or workflow engines if you have scenario to write to multiple tables in single transaction? Not multi-collection transaction, right? The transaction. Total multiple.
Bro, so in the reviews collection, you had embedded users information, right? So, so I've also seen in the other places where because you have the data there, whenever you're updating something, you're doing one more right? So my question is that, so what happens if my user information changes? Although it's okay to have a different profile picture when we are showing reviews, but still if I wanted to have that much consistency, then how would I? So will I delegate that to my application itself? And also one more doubt. So when you are updating the stats of, I don't exactly remember, you are updating the most recent reviews or something. So if you could just explain me how you are writing that query, I was a little bit confused there. Oh, this is the product collection, right? Oh, my bad. Yeah, got it. Yeah, got it. Got it.
Against the any supporting and have quite old system. So it's quite old. I've seen a lot of
Yeah, we can still take the questions, but we are running out of time. So we will be quickly wrapping up now. Thanks, Vivekanandan, for your wonderful talk on the data modeling. It was a very engaging and informative session for everyone, because you could have seen that in the number of questions we were getting from the audience. Yeah, so now we will be taking a high tea, and we will be taking the next talk at 11 o'clock sharp. Okay, so please feel free to move to the pantry area. Yep.
Hello, hello. Yes, because
Hello. I think it should come from.
like this you have to put. Hello, hello. Okay. Hello, hello. Because this mic will be used.
Okay. Hello. 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 I don't know how it looks now. Okay. So to sure. I don't have any other options, right? Okay. Okay. This is looks like okay. Is that okay? No, I'm okay.
We are starting in just 2 minutes now. Everybody, please gather in the town hall area.
This makes yes. Because they're already. I have started. It's not working. Yeah. Mm.
Hello, everyone. So we'll be continuing with our next talk from Ayushi. Ayushi, having a decade plus experience in the software development as well as in the DBA, she has experience in the MongoDB and multiple flavors in the SQL families as well. So currently, she is working as a senior database engineer in the Visible Alpha. Prior to that, she also worked with the uh, company like a Parcona and many others. So today she'll be talking about like how we can convert replica set into the sharded cluster. Two main features of the MongoDB. And yeah, one more thing, like if people cannot see the screen, can see there as well. So it will be, yeah, so there also you have. So if anybody cannot see this, can look after. Yeah. So now I'll be handing over the dash to the Aishi.
Thank you, Darshan. Uh, Hello, everyone. My name is Ayushi Mangal, and today we will talk about replica sets and sharded cluster. Before we start, I would like to know that how many of you never worked on the shards ever? Like, never worked on shards. Okay. Never worked on replica sets or never worked on MongoDB? Okay, so no problem. We will start with our presentation. So the agenda will be basically this presentation will be covered under two parts. That is why we need sharding. And once we find out the reason that now our replica set or our data set required to shard, then we will understand how to do shard to get all the optimized benefits from the MongoDB. So this is our agenda for the today's topic. We will understand replica set first and then the scaling part, then benefits and the components of the shard cluster. So basically this presentation is more about the architectural overview so that you will be able to understand how things work behind the scenes. Like being a developer, sometimes some of you may not aware that how the data will get stored, how the data get partitioned, or sometimes the query is not performing well. So you might get help with these things. Let's get started. So this is the replica set. So we have this three servers with us. One is primary and two is secondaries. So basically this is having a identical copy of data sets. Like you have a three data sets here. The identical copies will replicated via op logs to different servers. And the benefit of this replica set is to having a read scalability via secondary nodes. The client can read from all these three nodes, but MongoDB provides write permissible only to the primary node. You can write to primary and that data will get replicated to other secondaries. So basically this is just to maintain the copy of the data. Okay, so cleaner presentation you can see here. So this is the client. You can read and write from primary and you can read from secondary data. Okay, so the benefits of the replica set is high availability. So you can see replica set ensures you high availability in terms of like any node goes down, so other server is ready to take over as a primary. So it will come under automatic failover, and the data redundancy beyond your backup, you have that copy maintained inside your uh, secondary nodes. And the read scalability, if in order to offload the primary, you can have read scalability via different servers with different locations to get your different jobs done from other secondary nodes. In that way you can offload some of your load from the primary. Okay. So let's talk something about vertical scaling. So vertical scaling is basically when you are working with a data set in a single machine and your data set is growing and you want to improve your performance or any processing, so you are improving your ram disk or cpu to increase your capacities or performance in the same machine, but there is a limit to that vertical scaling. In that case, you will go with the horizontal scaling. So horizontal scaling is nothing but to segregate your data into a different shards. Okay. So here, sorry. Here you can see if your data is increasing, so your machines are getting more disk or RAM or CPUs. But next, in that case, your data is being segregated into multiple servers. So that will provide you a scaling in a horizontal way. So what will make you here ease will provide you ease here is you can add or remove as much as shards you want. So in MongoDB, horizontal scaling is nothing, just a sharding concept. That is, you can see shards. So shards MongoDB introduced as a concept of horizontal scaling. So here you can see it will have all the benefits of the replica. You can see you have the benefits of the replica, but you have a benefits of the horizontal scaling as well. Okay. So in MongoDB sharding, you can have a zone-based sharding. That is a different, vast topic, but I would like to introduce here. That is, you can segregate your data based on your requirements, like your application requirements. Like you can have a zone-based sharding if you want to distribute your data across the different zones, you can do that. If you want to distribute your data based on your application's requirements, you can do that, or a hardware configurations, you can segregate your data across the shards very clearly. You can isolate your data as per the requirements. Okay, so these are some advantages of the sharding. That is horizontal scalability. We just been through it. And the enhanced performance, it is something when you divide your data into the shards, you will get multiple parallel writes provided, so that is increasing your performance. Instead of writing one machines, it will write to the multiple servers. And the cost efficiency, how it will work. So cost efficiency is something you will get, like, you don't require all the machines on the one go. If your data grow, or if your data grow, you can remove or add your servers as per the requirements, so that will make your cost effective. And the isolation of data, as I mentioned here, is you can isolate your data as per your requirements needs. Everything is being under the zone based sharding. Okay, so this is something. Now we recognize why we need sharding, right? Any doubt here till now, or the horizontal scaling or anything? So let's proceed. How to shard? So basically, MongoDB provides sharding based on a particular data to get segregated across the shards. Okay. So how that will perform? So there is a key called shard key, that is a base of data bifurcations. Okay. So that is a base of that will require you min max key defined shard key to be chosen in a proper way, so that your data gets segregated in the required things. Most of the time we need to segregate our data in a proper way. Like if I want 100 chunks to be distributed in 5 shards, so 20 each, right? Or sometimes I want the geographic locations, then in that case. So let's start how to convert our replica set to a sharded cluster. So this is basically, we have this replica set under which we have this data. I want my data to be divided into these 3 shards, and this replica set to work as a shard cluster. So this is our initial setup, what we have. Now my requirement is that I need to make it a shard. So what we do? Okay. So let's start with this replica set first. So this is my primary and secondary machines where my data copy lies here, and I have this with the data. Now, if a client wants to read the data, what will happen? We will understand with this the component of the shard clusters as well. So what will happen? Uh, I want to copy this data to this servers and this data to that servers. So what the balancer will do is will move these chunks to these machines. Once the copy is being here, it got deleted from here. And if the copy is there, then acknowledge goes there and this got deleted. In this way, our data is being balanced under 3 shards. Okay. Now, this data is being segregated under the shards. But now how my client will know where I have to read the data? Will it going to hit all the shards? No, it will not going to hit and check every shard to where is my data. If I want this data, where is the data lies? So there is one interface called MongoS, that is the component of the shard cluster. This is the only interface via that the client can interact with the sharded data. Okay. So this MongoS, will this MongoS will hit all the shards again to check the data? No, it will not, because uh, to to make everything optimized, we have these 3 machines called config servers with us. So this config servers again deployed as a replica set, and that is a mandatory configuration setting to make the failover and everything works in place to get the benefits of the replica set. We have this config servers in place. So this config server is basically kept metadata information, that what data resides under what shard. Okay, so we have basically main 3 components under this shard cluster, that is MongoS, config servers, and these are the shards. Okay, so my any query will come and will check where my data resides if I want to read. So this metadata information will help to route that particular query in particular shards. It will not hit unless it's a broadcasting operations. Okay. So next question comes to my mind is how this initial replica set will be aware that I am a shard now. Like this is a replica set, right? So we deployed this as a shard server, new servers, but how this is aware? So there is a configuration setting called a cluster role for this configuration servers and this replica set. So I have to change this replica set to shard one. As I mentioned, we don't want our replica set benefits to lose, right? So we are keeping our replica set benefit intact. Along with that, we are adding one more role to it as a shard server. So we will restart this machines with the config setting as a shard server role, and we will deploy these machines as a config server role. And uh, this replica set is now aware that I am a part of this shard server. Okay. So, and here you have to mention that config server setting. So this is how my replica set got turned towards the shard cluster. So this is much better and a bit complicated presentation for the shard clusters. So components, as we discussed, this Mongo as okay, and this is config. Here we have 5 configs. So basically here we can also deploy it as a part of disaster recovery process. Here I have multiple data centers where my organization decided to move with some strategies in case of failovers or disaster recovery, and we have multiple shards here, and you can see replica sets are being deployed for each shards for each config in order to maintain the failover situations. Okay, so what we have learned so far is being explained here in the next slides till we go further with the shard of the collections. Okay, so shards okay, so this is a shard. Each shard store a actual data, config store a metadata. Okay, so this is a replica set one that is having a 3 machines, and here is my port where I have deployed this test environment. And this is something the that I was talking about the sharding and cluster role. So this we have to uncomment and restart our services. Okay. So with the restart of the services, we will be able to enable our roles. There is one example that I would like to show that how we can just convert our replica set to the shard cluster with the rules. So this is a Mongo as that we deployed, and the config DB we provided. This config DB you can see. Okay. I have kept the config IP so that Mongo S is aware of where to route for the data. Okay. Now let's check for the replica set setting. We'll check here. So replica set name and replica set setting will remain same, and we will just uncomment the sharding rule. So this replica set will aware now I am a part of this shard cluster. So you just have to change the setting, and similarly for all the 3 initial replica set members for the secondaries as well. So this is part of a replica set now, and we have to just restart this services. Okay. So let's start. So config stores metadata as we discussed, and it is deployed as a replica set with cluster rule. You can see this is my ports there where I have deployed this under port 37001, 2 and 3. And the similar IPs or the settings will provide to the MongoS to make that aware where you have to go via shards. Okay. This is the cluster role for config server. Cluster role required to enable in config server at the time of deployment. Here, no need to restart the service because you are deploying it as the new machines. Okay. So this is the Mongo S router, and it is the only interface you have for that client side to read and write the data. Okay. So let's see how we can connect to the MongoS and how we can add the shards. I'm just connecting to the MongoS where I have deployed on the port 27018. Okay, so sh.status is something you have to have a function to get the details of the shard status. RS represent replica set and sh functions represents always for shards. So you get that. So here is the one shard that I have already added. I am adding a new shard. Okay, new shard, you can see how you can add a shard. So you just need to mention the replica set name and the details of that particular shard. Rest, you just need to add primary shard. Replica set secondary members will take care by itself. You can see I'm just adding the primary member and rest uh, it will be taken care. So I have added one shard here. Okay, so you can see two shards you can see here, right? Shard 1 and shard 2. Okay, so my shards, and this is the shard status where you can see my active MongoS is 1, that is on 5.0 version, and other details. You can see chunk details here and shard key for the default shard keys, that is for config system sessions, and that is the default things. So this is how we added our shard via this MongoS. So this is something we get the details after shard status. If we want to see how many chunks we have, our balancer is running or not, any failed balancer attempts, or how many MongoS we have running, or number of shards and details, you can have like this. Okay. So let's understand. You have your base ready, like the shards ready and replica set converted. Everything is ready. Now you have to make a collection as a sharded collection. Okay. So for that, that is you required to enable sharding for that particular database name. And that is also prior to MongoDB 6.0. Now with the recent versions, you don't need to enable sharding for database. You just need to shard collection along with the namespace. Namespace is something with the name of the database and collections. And the shard key field. There are two kind of shard key you can define, like range based and hash based. If you are having some monotonous increasing, so I would prefer to go with the hashed. Otherwise, go with the appropriate shard key with the proper ranges. Okay. So this is example I have taken for a Toyota database for a cars collection, where I have just making that collection as a sharded to distribute my data across shards. So I have taken this two shard key as a ID and model. So this is an example of shard collection where I have just enabled Toyota collection as a database as a sharding. And let's before like creating a shard key, uh, you have to make that particular key as an indexed. Okay, otherwise it will not allow you to make that shard key. So I'm using that ID and model as my shard key for this example. So this is a very basic document you can see with brand, model, year, color, price documents, and I'm just creating an index with that particular, and then we will shard that collection. Okay, so first we have created the index, and now we will be able to shard that particular collection. Okay, so the namespace will be Toyota and cars, and then your shard key. This is my shard key, and my collection is being sharded now. So to check the shard status, you just need to check the shard distribution, how your data is being sharded properly or not properly, where your data resides with the min max key chunks and everything. So with the shard distribution, you can see this is the only 100% data is being reside on my shard one. This is only chunk one. So it will not getting any other chunk to get migrate from one shard to another, because I have not much data and it is only having one chunk. So I am inserting some of the data to it so that I'll get few more chunks to migrate the data. I'm just inserting few more documents to it and just checking if I'll get more chunks to migrate into another shards. So you will be seeing, right, that earlier it was only one shard being involved. Now you can see two shards were being involved with this data. See, this is both the shards are being involved and you have three chunks now with the division in both the chunks. You will see two chunks here, one chunk here. So this is how the shard works and how the data will flow from one shard to another shard after getting multiple chunks in order to balance between the shards. So now let's see the status of the shards that we have now. So you can see this is my shard key. That is, you can see if you want to find any shard key, so you can have here, and you can have the details of the chunks along with the details of the min key. What is the key associated with that particular chunks? Basically, chunks are nothing but a set of documents where like beyond particular size, it will break into multiple chunks and it will migrate to the shards. Okay, so shard keys. We are like saying multiple times shard keys, shard keys. So there are a lot of things with the shard keys associated with. So we cannot, go and just choose the shard key blindly, because sharding is something which is easy to deploy. But going forward, you might have, uh, poor performance, or you might end up with some mess up. So it's always to choose a good shard key, like good cardinality. If your shard key is monotonous, you need to perform with the hashing, and frequency of the document for that particular field should be there. If you are choosing a poor shard key, then with the time, with the increase of the data, you might end up with the jumbo chunks. Jumbo chunks are something which balancer will not be able to migrate data by default, and you might end up with non-uniform data. So that is again a part of vertical scaling, where your one server will end up with a lot of data, but other server might end up with the emptying the data, so decreasing query performance and all. uh, if you choose the shard key, are you able to change the shard key afterwards? In prior version, shard key was immutable. Like if you choose the shard key and if you want to change it, you cannot. You have to dump and restore everything again. But with MongoDB 4.4, it allows you to refine the shard keys. That means you can add, with that particular existing shard key, you can add more prefix to it to make it more optimized in order to distribute your data load. With recent version, like after 5.2 and later, you can be able to change your existing shard keys. And there are some limitation with the shard key, that is your 4.2 and prior version, your shard key size was 512 bytes, and now there is no limitation. You cannot create a descending index with the compound index if you are using. Okay. So these are some considerations and best practices we have. That is strategy and planning. Like if you are deciding that your data is being growing a lot, now you have to introduce shard in your organization. It's always a good practice to discuss about the requirement. Like in our previous presentation, Vivekananda also explained that queries, you do to know your queries, right? So it's always important to know your queries, to know your application requirement, what kind of queries, like it's read intensive, write intensive, or what kind of reads you are going to perform. On the basis of that, you have to plan and then deploy your shard clusters, everything in place. And then choosing the right shard key is very important, as we see that query patterns, uniqueness of your data and everything. And then monitoring and troubleshooting. So monitoring and troubleshooting, with the time you have to monitor each and everything. Okay, so I just have last question with you. before you are going to ask me. So anyone can now explain me what is the difference between you understand that primary member of replica set and a primary shard? Anyone get an idea now? Correct.
Primary member of replica set, is it the config?
No.
The replica set which serves both.
Correct. So there is no, interlink between these two things, because I have seen a lot of people get confused between these two terms. Replica set primary member is a replica set primary member that we saw. Like it is for read write purpose. But this primary shard, as you mentioned it right, that is for a particular database. If you are having a database and under which you have multiple collections, some of being not sharded, right? So that will reside under that primary shard. So both terms are different. Yeah. Thank you.
Replica set to shard, right?
Right.
But even sharded collections will have replica set, right, to have high availability.
Yes. Every shard has a replica set with it. Yes.
And number of shards. Do we define number of shards while sharding, or it's the number of servers in the cluster will be number of shards?
No. It is like dynamic. If you want to add on the go, like if you have two shards now, you can have one more shard later or one more shard later, and then data will distribute accordingly across all the shards.
By default, number of shards will be number of servers in the cluster, is it?
No. You can even have a single shard server as well.
Say that I wanted to remove like one of the key and then make a new one. So should I restore the complete database and do that?
No, it was required in previous versions, but
Okay.
not now. Yeah. Earlier it was immutable, just shard key, but
Okay.
now you can.
So I can directly remove it.
Yes.
And then
Change it and then it will rebalance.
Okay.
No, it is because rebalancing, yes, rebalancing is something when your data is migrated, it is maintaining the copy. Unless it acknowledges, yes, I received, then it will get metadata updated in the config and then it will get deleted. So everything is what's going on will be this like having information in config server. So it will know I have to go to this shard or that shard. If that delete, it will go to this shard.
Hi, my name is Onkar, and I was one simple question. Usually, what we do is we use a single column as a shard key. Now, there are certain situations wherein the single column is not the decisive column for a given collection. Say for an example, if I go for sharding based on cars, then model also comes into the picture.
Correct.
I'm working in healthcare domain. So in healthcare domain, a patient can visit multiple times to a particular facility and, multiple different hospitals of the same facility, right? In that case, how do I use composite key as a shard key?
Yes, so it is always good to understand, like you mentioned, the client details, right? The patient details. So your compound key should be like with proper cardinality and the frequency of the data, so that you will have a proper segmented data or chunks being created. If you end up with a single, let's say a single entity which has a multiple documents can it, so you will end up with a jumbo chunks or might end up with a single data being overloaded on the same side. So it's always good to have the data understanding and then decide your shard keys.
So the answer is yes, we can use composite key as a
Yes,
shard
yes,
key, right?
yes, we have to use for composite keys only for the range based sharding.
Okay, thank you.
So my name is Anju. I had one question. So on the last slide, you have shown that monitoring is there for the sharding. So
Yes.
what if my primary shard? So data will be distributed between the shards as a chunks.
Correct.
On the first shard, I have chunk A. Suppose my replication is not working. Second and third, the replication were down. So all
Okay.
of a sudden, if primary chunk went down, primary shard went down, what happens to my chunk data?
You are saying part of a shard goes down, right?
Complete shard.
complete shard, like shard ABC, shard A goes down,
Yes.
but your cluster will be working partially. Like you will not get the data from this A, but you will get the data from B and C.
What happened to the data on the A? So
You
what it was like if
you are maintaining replica set for that, right?
my
If
question is
if everything goes down,
like secondaries are down.
yes. So in
Suppose
that,
my monitoring is not working,
okay,
secondaries are down. I'm having only primary on the shard. Will I
okay.
get any message, something like that on the primary shard? We are not having the replication. There is a chance of a disaster if shard one down.
No.
You said that the
This is,
monitoring is there.
yeah, this is the reason I'm mentioned that monitoring and troubleshooting should be there. Monitoring is always there, because if you are saying shard one has 3 nodes,
Yeah.
right? If any one of get down, then also you will get the notification and you have to work accordingly. If two goes down, then your single machine will never work as a primary. It will went to the read only mode as
Okay.
per your that rule, right?
Okay.
So it will went to the read only machine. It will not a single primary machine.
Okay.
So you should always watch your alerts in order to not get into that situation.
Okay. I thought if there is any message when we log into the Mongo shell, will it give any message,
Yes,
something like that?
if you are reading the data, you will get that there is no shard one primary available. You will get that message.
Okay. Thank you.
There is no primary member found करके. You will get that message.
We can take one last question. Okay.
Could you please throw some light on this zone sharding
Yes.
and as well as global rights, how to enable those? Is there are any, hiccups in that?
Okay.
Yeah,
So zone
when we are
based.
managing through Atlas and all.
Okay. So zone based sharding is completely a very vast topic in itself. But again, I would definitely like to answer this. Zone based is something was known as tag aware sharding earlier. If you want to use that particular data segregation, you can just divide your data based on the tagging of that particular shards. And that is available in Atlas also, right? You can add the tags in the shards. Yes. Thank you, everyone.
Okay. So today we would like to. So basically, if you see, today you have seen like how you have to use MongoDB, how to do sharding, and all those things. And recently we came across a use case where we had to do some search capabilities enhancement on our platform. And we actually leverage MongoDB to achieve the same. So we would like to talk more about that, like what we did, how we did. Before that, I would like to talk about basically what we do. So we are SaaS, CRM SaaS company, where we are having more than 1 billion customers data. We are having more than 250 plus brands onboarded onto our platform. We are running more than 400 plus loyalty programs, and more than 600 billion points has been awarded by system and claimed by the customers. So basically our platform supports loyalty, insights, engage, customer data platform, and rewards. So now coming to the problem. So previously we were more focused into the retail. And if you see in retail, mainly people are interested in who are the customers, what are they buying, right? So they are mainly interested in, or if they have to search, they will be looking for the customer, and they will be looking for what transactions they are doing, what is the coupons assigned to them, or you say what are the points of value they are holding so that they can claim that. So this with this, it was much easier if we are holding. So basically, our customer data resides in Aurora. So if we have to search the data, right? If I am having customer identifier, I can directly go ahead and hit the read replica of that DB, right? And it would be much easier. But because we are a multi-tenant company and we start pouring into other verticals, like we said, we will be moving in supporting hospitality, we will be supporting aviation sector, right? So in those sectors, the search, right, which we are saying ki you can directly go ahead and search on customer, or you are having that bill number and you can search on that. But in those basically sectors, that is not the thing. So if you see, if you go to any airline website, basically they will ask you what is your PNR, right? What is the last name, or what is your email, right? So basically they say ki we are having composite data and we want to allow search on that. Similarly, if you go, sorry, so basically, so what was happening? Our current system, right? That was bit of providing homogeneous search. So it was saying you can search on customer ID, or the mobile number, or the customer identifier basically, or you can search on the bill identifier. That is nothing but your transaction numbers and other things. But because now we are expanding and we are trying to support different verticals, so new use cases came into picture. That was the one of our challenges. So that was, we are saying ki these are the heterogeneous use cases, no more homogeneous, because now we have to provide that search on different parameters. Then if you see, if we are allowing that, right? Generally, if you have to search something, you need index on that. Then how the scalability will come into picture, how you will scale your system with these kind of different use cases. And again, if you are searching something, right? So you want quick results. You don't want to wait forever to get those results. So the performance, which should be up to the mark. If you are saying my search result will be delivered in 100 milliseconds, then it should get delivered 100 milliseconds, mostly 95 and 99th percentile of time. So if you see, we already talked about it. So we were having these heterogeneous use cases where if a tenant in multi-tenant environment is airline client, and another one is hospitality client, and another one is retail client, then basically they will be having their different use cases by which they would like to search the data. So this was our old architecture, which was having the problem because that was very specifically designed to search the data based on fixed identifiers. So we were having our core data platform. We were feeding all the data to our database, and then we were having Solar as our search database. So if Solar was not able to respond within the given time, our core database was hit and was serving the customers. Now, because we are saying ki now any tenant can come and they can say ki I want to search on these parameters. We say ki people are saying ki we want search based on certain criteria. So they want to define certain criteria that can be their use cases, right? And those cases may not be limited, right? Even if we are saying ki airline is saying ki I want to search with PNR and last name, they may also say ki I want to give a search on PNR plus first name, or they want to also give a search on the email of that customer, right? Or maybe if they are having some loyalty card, which is given to the customer because they are loyal customer, they can say ki you can search based on that loyalty card. So we said ki you can define your search criteria, which may be n number of use cases which you want to cater, and then basically based on that criteria, we have to build those indexing strategies by which we should be able to index our data. Because if your data is indexed, you should be able to serve it. So to do the same, so what we said, ki, if you are storing data and in your any of the SQL store, basically you cannot define those many indexes. That is not possible. You cannot say ki this is some custom data. If you see this example, basically here, we are having different fields, right? If this data is kept in any SQL store, basically you will be saying, I will be defining indexes on those fields, and then I want to search. So how we solved it, we said ki, because MongoDB is schemaless, right? So we can say ki I can store any data in the same collection. So what we did, we defined one top level, you can say collection, where we said ki the document structure would be having certain fixed parameters, which are nothing but your tenant identifier, your criteria identifier, and the identity identifier. And then we defined field from field 1 to field 10. And we are saying you can search, or the search capability is limited up to 10 fields. So more, if you want to search more on more than 10 fields, you won't be able to do it, but any number of fields less than 10 should be able to basically should be able to search using our strategy. So what we are doing here, we are saying ki we are having criteria, and in criteria we are defining ki what all your fields on which you are looking for that search capability. So like in case of airline, we are saying ki you can say ki PNR plus origin and destination and flight time. Based on that, I want to give the search capability. While in another case, you are saying ki mobile plus first name and last name. Based on that, I want to give the search capability. So if you see with MongoDB, because the index is created on all those fields plus the base structure, you should be able to serve even though the same collection is having all the data. And you need not to create index, or you need not to create a schema on the go to support all those criteria. The same collection should be able to serve different criteria you are having. So now in our system, whenever there is a change in the state of the system, so basically now people are looking for mostly real-time search, or maybe delayed by a certain time range. You are saying that 30 minutes is acceptable. If data is coming after 30 minutes, then it is fine for us. So in our case, whenever there is a change in the state of the system, an event is raised in the system. So we utilize that, and we are saying that based on your criteria, we will be maintaining all these data in that collection, which we have already discussed. Whenever a data is arriving. So we are keep on feeding our search data platform. Basically, we keep on entering data into that collection, and that allows to search the data. Now, the problem with that is because the client might be onboarded onto system 1 month back, right? But today he said, I want one more search capability. Previously, I was allowing people to search data based on suppose PNR plus last name. But today I want to enhance that to PNR plus first name, right? Then we should have that data because we are keeping the redundant data. So this data should be also there. Then only they will be able to search. So to support those scenarios, what we did using our OLAP system, we are feeding our system basically to reach to the same state. Suppose I'm starting today and I'm having 1 month old data. That 1 month old data will be fed via our OLAP pipeline. And by end of every day, right? Because we may miss on certain data via those events, right? But that should appear in that search result. To do that, we are doing a reconciliation pipeline that again basically tied back to our OLAP system. So by end of the day, it will sync it back so that if some data is missed, by next day, it should be readily available for search. Also, while designing the same, we ensured if tomorrow we have to provide certain search, because if you want to give some regex based search or something, right? Then MongoDB might not be a better option. Then there might be alternatives for that where we want to do that. In that case, what we said, we did the interfacing on our search platform, and we said whenever you want to expand it to other databases, you should be able to do it. You just need to implement that interface and it should be available. Then, so basically, if you see, right, the this is why we have used MongoDB and not any of the search stores, right? We might have used Elasticsearch, right, or the other options. So we have chosen MongoDB because in our use case, right, we wanted to optimize it for cost. We wanted to optimize it for the solution. So basically, if you see, if I have to use Elasticsearch and other, right? So based on each search criteria, I need to create a schema and I need to feed that schema. And then whenever I'm searching the data, I should be searching that against that schema. So if my search criteria keep on growing, then basically I will be keep on adding those schemas into my system, and the solution won't be that simple. But if you see over here, the solution is very simple because we are just keeping it within the same collection, irrespective of number of criteria. So that's where the schema-less feature of Mongo helped us to achieve it. Then if I'm giving certain search capability, right? If I'm searching on transaction or if I'm searching on, so there is certain time frame, right? Each tenant might be saying. So if you are searching PNR data, you might not be interested on the PNRs which is 1 year older or maybe 6 months older, right? Or maybe which like already travel happened and travel happened 6 months back. So no one wants to search on that. So we are expiring those documents based on the auto expiry. Basically, we are setting auto expiry for those documents in that collection, and it will get auto expired, and that comes out of the box for MongoDB. And then, as we have already seen, we can create shards, right? And anyways, it is running in replica set in MongoDB. So scalability wise, we won't see any challenge, and we said it will be highly scalable. And cost wise, it was way lesser than the Elasticsearch because we are having our self-managed instances of MongoDB. So it was much cheaper for us, and cost is always a factor when you are building any new feature, right? Because you have to see how much ROI you will be getting out of it. So performance-wise, we tested it on 50 million records, which was like whatever 5x of the basically data which we were expecting on per shard. And we tested it against 1000 RPM. And at the same time, upserts were also happening. So it was not like we have just feeded our database and we are just trying to do the search. It is like when we are doing those search, our data was continuously feeding the data. Basically, it was updating certain records or it was inserting new records. And the response time was less than 50 milliseconds, which was good enough for us. So basically, the conclusion wise, whenever you are looking for any solution, so sometimes things might sound intuitive, like if you are searching, then let's go to any of the search engines. That will be help me. We were also thought Elasticsearch will be a better in our case, but when we analyzed and basically ran our test, MongoDB was sufficient to achieve that, whatever we were looking for. So like if you want to kill someone and knife is enough for it, you need not to use a blade. So I would say that's it from my side. So I'm open for questions. No. We don't use MongoDB only for the
No.
search
If
feature.
you see Elasticsearch or Azure Search, right, it has
Yes.
other capabilities like fuzzy search, filtering, faceting, etc.
That's why we have created the interfacing. So we were looking only for start with kind of thing and the exact search.
Okay,
so our
exact
use case was limited.
Okay.
So if we have to expand it further, then we might, if fuzzy and all those logic we have to use, even the regex based search and all, right?
Yeah.
Then we might need to
Go for other solutions.
So basically, we have to implement that interface, and we have to say what is the criteria, right? So as of now, we are thinking we are looking for exact match, right? Or we are looking for starts with. Then we will be saying I'm looking for regex based, or I'm looking for the fuzzy logic. Then accordingly, it will route it to the downstream system.
Yeah. One more question. You're multi-tenant, right?
Yes.
So for single collection will have multiple tenants data, and you gave
Correct.
10 search fields for each tenant, correct? So number of fields on which you create index at max can be 10 into number of tenants, right? Am I right or
So
wrong?
basically, we are having only one index on this.
No, you given 10 fields, right?
10 fields, all the 10 fields are included in the same index. So if you see, that's why we have given it as field. We have not created the specific keys.
Okay.
Otherwise, we might be having the issue of sparse index. So if you see, if you are having 3 fields, even though index is on 10 fields, it will be hitting because these are the first fields, right? So it will be giving you the same performance if there would have been an index on these 3 fields.
So if a retail customer logs in, then you know that first field is PNR. That's how you do, is it?
Yes, yes. That's how it is dictated by the criteria. We store the criteria first.
Just to elaborate what his first question was.
Mhm.
Search, you told exact only, right?
Yes.
But MongoDB latest has Lucene included, etc. Right?
But that was not required for our use case as of now. So
No,
we
no,
have not explored.
I'm just adding what you were suggesting. Like MongoDB only support exact search. It's not like that, right?
It's
Lucene
not
and all.
like that. It's not like that. But
Lucene and all is introduced
yes,
in MongoDB
yes,
as well.
yes. But if you see like the response time and all, right? Those also you have to consider based on your data set. So it might be having that feature, but it may or may not met your response time. Please have information.
Hello there. My name is Jay. I must say it's a really excellent presentation. So my question is that can you touch up more on why you have chosen MongoDB over Elasticsearch, given that you mentioned you have seen a reduction of cost when you are going with on-premise, you have self-hosted MongoDB. So, like, if you could touch up more on why you have not chosen Elasticsearch over this.
It's more of you can say the simplicity of solution and the cost both. So if we would have chosen the Elasticsearch for each criteria, right? Because each criteria is different and might be touching upon different level of fields, and the number of fields are different, right? Then the schema in Elasticsearch, right? I need to create multiple schema accordingly.
Okay.
Then that solution becomes more complex because every time someone is adding a criteria which is not uh, matching any of the schema present in the Elasticsearch, I need to go ahead and create a new schema every time.
Okay, got it. So my second question is that, so we have, so you have put a compound index, right, on all the fields that you're searching for, like a
Yes.
generic compound index. So now, if you had to shard, you are sharding, right? So which index would you choose?
So we already have our tenant ID, right?
Yeah.
So we mainly shard on the tenants.
Okay. Yeah. Got it.
Yeah, I liked your quote. Use knife if if it's able to solve your use case. But do you think we should focus on current use case, or should we consider future requirements as well? In future, you might get requirement to include other search features like fuzzy
Yes.
search, etc.
Yes. So I would say you should consider both. So when you are solving, right? So your solution should be able to solve the current use case as well as should be able to extend to the future use cases, right? Like we did interfacing, right? We did interfacing because we wanted if tomorrow we have to incorporate any other kind of search engine, which like if tomorrow we say we want AI based search, right? Then we might not be able to do it using MongoDB. Then in that case, that interface need to be implemented, and we know our system would be able to, without modifying much part of it, should be able to serve that. And then for current use case, we are saying because it is sufficing for 5x or 10x of the traffic, which we see should suffice us for us maybe next 5 years, then we are good.
Thank you.
Thank you all.
Thanks, Deepak, for the very constructive talk on the search cases and explaining the in detail, details for us. So that comes to an end. Before that, I call Yasin to give a closing notes.
Darshan. So we love hosting these events, right? And we've probably done 17 of this in Chennai before we started probably our very first one here. So I think I'd like to close out this session with thanking all of you for registering, signing up, taking time out of your busy lives to come and participate uh, and be here with us today. Special thank you to Darshan for organizing and hosting most of this event. Thank you so much. Thank you to the speakers who took time out of their busy lives, created all the material. So Vivek, Ayushi, Deepak, thank you so much putting together engaging presentations. And hopefully we've all learned something from their knowledge and experience from this event. So thank you so much for that. And of course, finally, our team, Anita, Chaitra, Rakesh, Suresh, Mohan, for, it takes a certain amount of effort and commitment to get all of this set up and making sure that we have a good experience on this day. So thank you so much for putting all this together and pulling off a great event. I feel it went very well. So I hope you all had a good time.